Hi Pre-Algebra, we are back today with 9.5. Grab your interactive notebook, have your textbook open please, and we will get started here. So slope is how fast a line that we will graph, and we just talked about lines yesterday, how quickly it goes up or how quickly it goes down, how steep it is. I guess steep is a better word there. So before I kind of draw this, you'll probably see that skier. You've let's see, get that on. Okay. You've probably been skiing before or know someone who's been skiing. So you would have a skier, and he'd be more bundled up than this, but just imagine, okay? So he's skiing, and here are his skis, and he's going to be going down the hill, right? Okay, put a hat on him. Okay, so if he's coming down this hill, you could begin when you're first learning on a little baby slope, right? The bunny hill, not very steep. But if you progress and you learn and you are excited to ski and you want to try something hard, you might have something even steeper than this. And maybe you're on a black diamond. And you have to try to figure out how to get down even with trees and other things in your way, whatever it might be, okay? Which one of these is the steepest, right? Well, the black diamond, right here. Which one is the least steep, right? Well, that's where you're starting with the bunny hill right here, okay? Now, you can either go up a hill or you can come down a hill, right? Your hill could be coming this way. You could be going down the hill. And we're going to talk about that a little bit today. It matters which direction, from left to right, which way you are going and how steep it is, okay? So we're going to talk about this in terms of rise and run. And let's put a few definitions in. So if you'll write these 3 words in your interactive notebook, we are going to add a few words here. And again, remember that this pen doesn't work so great, so bear with it looking awful. Okay, so the slope, I'm going to kind of jump down to slope first because we need to know that. This is how steep. I don't really like the definitions in your book, so make sure you're writing this down. It's not what's in your book. How steep a line is, and if it goes uphill or downhill. 2 choices there, okay? Okay, now the part that I do like about what your book has is very true about slope, but I think that it helps to kind of understand this part of it first in more generic terms. But it is the ratio or the comparison between the rise and the run. Okay, so what is the rise? The rise is the vertical change. If something goes up and down, how much do you have to go up and how much do you have to come down to go from one point to the next? So this is vertical change. So what would you think run might be? Good, horizontal change. Okay, so our slope is going to be described by the letter M, and it is going to be equal to the rise divided by the run. We will generally say rise over run. Sometimes we'll say the change in Y, because Y is your vertical axis, over the change in X. Now this triangle here is just the Greek letter delta, and it stands for the change in. All right, so if you have nothing else, please make sure you have this right here. This is really important. This is going to be the formula that we will use, and we'll have it in our notes here in the future too. All right, so how much it changes up and down and how much it changes across horizontally. Okay, now this was a lesson that we were going to kind of walk through, but I'm just going to give you, we're not going to do it all. We're just focus on this part. Okay, so let's say we have these different stairs, right? So you've got these orange stairs here. They start and they come up. And, oops. So it comes up a foot and then it comes over a foot. And different stairs have different dimensions, right? So 12 inches up, 12 inches across. Some stairs, I have some friends who have a very old house and their staircases are so narrow. If you don't walk up sideways, your foot won't fit on the whole stair and it's really easy to fall. So it's a little dangerous, but it goes up quicker. Like you don't have to use as much space in your house for that staircase. So you might have a staircase that looks kind of like that. In this case, that staircase is still getting you to the same point at the same time. It's just using a few more stairs to do it. Okay. Now what if we had this staircase? This staircase is not as steep, right? So it would be a little bit better for kids maybe, or for older people, right? It comes across, you have a whole foot across, but it only goes up half of a foot. So every half a foot it goes up, that's your vertical change, and this is your horizontal change right here, going across. Okay? You might have a staircase that comes up just like a quarter of a foot and comes all the way across an entire foot, right? This is definitely not as steep. Do you see the slope here? This slope goes up a lot quicker. This staircase is going to take up a lot of space in your house, this purple one. Now, if it's outside or if you're at some park arena, that might be exactly what you want to have outside. Okay, and this last one goes way across. Okay, this one is not very steep at all. So what we could compare would be how much it goes up, vertical change, right? Change in Y, over how much it goes over. If you had a staircase that looked like this, goodness gracious, that would be hard to climb, right? But it certainly would not take up much space, and you're going to get up really fast. So if your change in Y in relationship to your change in X, if this one on the top is bigger than the one on the bottom, you're going to go up quicker, right? Now, what if I had a staircase that looked like this? That is going to go up really slowly. And maybe the change, let's see, this is a little bit sloppy here. The change in Y might only be 1 over the change in X. Excuse me. Maybe this would be 5, right? 1/5. So the smaller this number is, or the bigger the denominator is, the least steep it might be, right? It's, approaching, could really even be really, really not very steep going up. Okay? Does that make sense a little bit? This is slope right here. So go up your stairs at home and try to figure out what the slope is. Measure how high it is and how far across it goes. Okay. Here's my formula again. Right here, right? The rise over the run. I'm going to add this whole change in Y over the change in X. I think that's still pretty important. What if we have a line? Could we figure out what the slope is? This is literally the only part on your homework tonight. Just here's a line, find the slope, okay? So our step 1 is going to be to find 2 points. Now, I'm given these 2 points on this line already, point A and point B. Now, if they are not given to you, you will need to find points on a line. Now, it's really important that you don't pick, like if I picked this point right here on the line, that would be kind of hard because, I don't know, what is that? 2 point something over 1, 2, 3, 4, 5.6 maybe? It's hard to tell. It's not exact. Okay, now, are those points not on the line? Could they not still give you your slope? Yeah, they can, but that's not going to be very accurate. You want to look for a line, a point on the line that intersects exactly at 2 of your markings for your graph paper. Does that make sense? So these 2 blue lines, they cross right here. So this is a good point to pick. This right here is a good point to pick. There's another one right here. Okay, so when you tonight are looking for points on your line, it's really important. Pick points that have whole numbers for their ordered pair that goes with it. Okay, this has an ordered pair of -1 and 1, 2, 3, 4, 5. Okay, make sense? All right, let's get rid of some of that so it clears this up a little bit. Okay, so that was step 1. Done. Use the formula. How much does it change? Well, let's see. I need to know the change vertically and the change horizontally. Okay, so here is my vertical change right here. -3. Okay, it goes from this point 1, 2, 3, goes down 3. If it's going down, that's negative. And goes to the right 1, +1. So what I need to do is put a -3 and put it over a +1. Now, if you're worried about knowing if it's positive or negative, I want to show you a trick. Yes, that's important. Well, let's come to our answer here first. A -3 divided by a +1 is just a -3. And you can always leave it as a fraction, but if it's a whole number, just simplify that. So the slope is -3 for this line right here. That's the answer. And you would write it like this, because M is the letter we're going to use to determine or to stand for slope. Now, I want to add some things here, and please make sure you put this in your notes. If not much else, this is really important. If you have a positive slope, your line goes up from left to right. It's uphill if you're skiing. A negative slope goes downhill when you are skiing from left to right. Okay, so from left to right, these are really, really important. So if you look at our line here, this is a downhill slope, right? So downhill slope is negative. Did I have a negative number? Yes, I did. So really what you can do is you can just count this number here. You can say 3 and count this number 1 over here and then say, okay, but it's going down, so I know it has to be a -3 over 1. Okay, so it really doesn't matter which one your negative goes with. But if you do want to do that, you can just go by, if it's coming down, it's negative. If it would go to the left, it would be negative from one point to the next. Like you're starting at A and you want to follow the streets to get to somebody's house at point B. You can't cut through the yards. You have to go through the streets. You can think about it that way too. All right, why don't you try some on your own? Go to page 369. Try skills check 1, numbers 1 and 2. Remember, when you plot the point, find a point that's exactly at an intersection of the blue lines on your graph paper so you have whole numbers. And pause the video and let's check them together. All right, so for skills check 1, let's see. Let me put a picture in here for you. Okay, so here's our line. And I'm going to pick this point right here, and I could pick this point way over here if you want. It doesn't matter which 2 points you pick, you will get the same answer every time. So I want to know my vertical change to go from one point to the next, right? So to go from my point A to my point B. Doesn't matter which one is point A and which one is point B. Okay, I want to make sure I'm using the right colors here. And my horizontal change goes across this way. Okay, so my vertical change is 1. Now, if you are, let me zoom in a little bit here. If you are not using bumps to count them, it's easy to count this wrong. I have to start at point A, and I'm going to count 1, 2, 3, 4. Does that make sense? This is not 3. This distance is 4, right? This whole thing. There's 4 blocks. And here it's 1, 2, 3, 4, 5, 6. Okay, so let's come back to here. So this is a 6 and this is a 4. Okay, now if you are doing the positives and negatives, both of these would be positive. You're going up and you're going to the right. Both of those are positive. Okay, so I would have 4. The change in y is my numerator, and then my change in x is my denominator, but 4 6 can be simplified, right, to 2/3, which is the answer. Now, you might have picked this point right here instead of all of this, and that would have made it where you have 2/3 already. You just have this little section right here in red. Okay, same slope. Now, could you count these down this way? You sure could. Let's say you picked this point here. I could come down. What is that? 1, 2, 3, 4, 5, 6. And I could go this way. So you would have 2 negative numbers. You'd have a -6 and 1, 2, 3, 4, 5, 6, 7, 8, 9. and negative 9. So what is a negative divided by a negative? Well, it's positive, right? So you still get 2/3 either way. Doesn't matter which way you graph all of those. Okay, and the answer for number 2, I should have said this before. See how it's going uphill from left to right? So we know our answer has to be a positive number. Here I'm going downhill from left to right, so I already know my answer has to be negative. I don't even have to worry about anything else. I already know it's negative. And then I would find my 2 points. The closer together they are, the less reducing you have to do. This is 3, and this is 2, so I get 3 over 2, and I know that it has to be negative because it goes downhill, so m equals negative 3/2. All right, the last thing that we need to do is look to find the slope if you don't have any picture at all. What if you only have the points that are given to you? And you can do it. It just requires a little bit of math. We have to basically say, hey, if I know these points, I could just add or subtract to find this distance, and I could do the same thing here. Okay? All right. So in order to find the slope, I need to, here's my previous formula that you had, same as before. But I want you to add this to your formula right now. Take a minute, stop, and pause this if you need to write this down in your notes. I'm going to have point number 1 and point number 2. And point number 1 has both an x and a y coordinate, right? So we're going to call that x1 and y1. These are little subscripts. And you would read this as x1. And it doesn't mean it's to the first power. That's up here. This is just noting. It's just like a little notation. Like, hey, this is my first guy, my second guy, or might refer to going to some point for something else, okay? All right, so that's x1 and y1. So then if this is point 2, then this would be x2 and, good, y2. Now all I have to do is substitute. So this guy goes here. This guy goes here. Okay, now I'm going to mark up the whole thing because it'll get confusing. Okay, so what is my slope? My slope would be y2 is 5 minus y1 is 2. All over, see, that's kind of like counting from here, 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 right? We'll get 3. It would be like we had counted 3 marks. Okay, and x2 is 7 minus 1. So that equals 3 over 6, or 1/2. So my slope is equal to 1/2. And if it is a positive, we know it has to be kind of going up. Okay? All right. So, actually, let me back up here. How do we feel about this one? Take a minute, try a couple more. If you don't fully understand this, that's not going to matter too much. Let's make sure. So on your homework, all you're going to do is be able to look at a graph. Okay, if you want to try some of these, there be a great challenge problem. You could try number 13 through 24, and we will talk about what that looks like more next year. But just want to kind of give you this as an idea. You won't have to do too many of these, okay? All right. Let's practice a little bit more, and we are going to also put the graphs of these up because we have 2 unique situations. This is the last thing we're doing. We could have some line that goes up like this, right? That's a positive slope. We could have a negative slope. But we also could have a line that goes straight across. That doesn't go up or down at all, right? If you're on skis, you are not moving anywhere unless you're cross-country skiing and you have to use your arms. You could have a vertical line, and goodness gracious, you'll fall off the side. This is a nut hook. You can't do this, right? So these are my 2 unique situations. When you have a horizontal line like this, your slope is equal to 0. When you have a vertical line like this, your slope is what we call undefined. You can't define, there's no slope here. Okay, an undefined slope. These are my 2 unique situations, and really important, you will be seeing these. So a horizontal line, 0 slope, vertical line, undefined slope. And that would just be your answer if you saw something like that, which you will tonight. How do you do that with just 2 points, though? Well, let's look at it. We're going to end up getting a 0 somewhere here. So we're going to label these as x1, y1, x2, y2. Okay, so let's plug some of these in here. My slope equals y2 is 2 minus 2. And I have for my x, I would have -1, right? x2 minus, 3. Okay, so that gives me, 2 minus 2. It's just 0, isn't it? And I have -4 on the bottom. Well, anything divided by -4 is 0. So this, what kind of a line is this? This is a horizontal line right here, which, look at these coordinate points, right? Doesn't that make sense? Let's put this in and look at this together. Okay, so let's draw or plot these 2 points, okay? So we have a 3, 2, so 3, 2 would be right here. And we have -1, 2 would be right here. So do you see how that makes, a horizontal line, right? There's no vertical change. Look, no vertical change. The top number is your change in y, or a vertical change. If they're from this point to this point, I don't go up and down at all. Okay, so if you don't go up and down at all, there's no change. That's the top. It doesn't matter if I start from here and go all the way over here. This comes over 4, which is why we have a 4 on the bottom. You could pick a point way over here and a point way over here, and you could have a 100 in the bottom. It doesn't matter. You'll still have a 0 on top. It's a horizontal line. Okay, now what happens over here? Let's plug these numbers in and we'll just kind of see what happens. Okay, x1, first thing is a label, right? y1, x2, y2. Whatever number you have first, just make it 0.1, and the point you have second, just make it 0.2. Okay, it doesn't really matter if you switched them, you'd still get the same answer, so long as you are consistent for both of these in here, and this coordinate point to both be x1 and y1. Okay, so 6, right, minus 1 all over x2 is 3 minus 3. Oh no. Gives me 5 over 0. Well, something you may not realize, can you divide anything by 0? If I give you $5 and I say, hey, put $5 in 0 groups, you can't do it. You at least have to have it in one group, right? If I put these $5 bills right here, there's no way. You have to have them at least one group. This is called undefined, right? Okay, it's not possible. You can't do that. There's a mathematical error. So let's try to see what this looks like on the graph. Let's move it a little bit smaller here so you can see it. Okay, so let's plot these 2 points. We had 3, 1. Oops. There we go. Oh no. 3, 1. Thanks for bearing with us, guys. And 3, 6. What happens? Okay, that is supposed to be a straight line. Just imagine. There we go. That's a little bit better. Straight line, right? Your slope is undefined. And you can just abbreviate it like that if you want. Because it's a vertical line. There is a change from this point to that point. There's a vertical change of 5, right? But there's no horizontal change at all. It doesn't go at all over across. Okay? So that's what you call undefined. All right, those are the 2 unique situations. Go knock out your homework. Pick your points. Count up your slope. Check your work. If I were you, again, kind of like what we did before, start very carefully. If these are your 2 points, count 1, 2, 3. I still sometimes draw little humps on them because it's just so easy when you're looking so closely at a graph to mix up what you're counting, not your math necessarily. Okay? All right, we'll miss you guys. See you tomorrow.